All right, number 12, we want to determine whether the graph could be the graph of a polynomial function. If it could, list the real zeros and state the least degree. All right, so this looks, pretty much like a smooth curve. It crosses 1, 2, looks like about 3 times that we can tell. We don't know what happens on the other end or what happens further down the graph. So it looks like we need at least a third degree. And you can see turning points. This is what they mean when they say turn. The graph is going up, and then it turns, and now it's going down. So that's 1. It's going down, 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 and then it turns, and now it's going up. So that's 2 turning points. So from what we've talked about, your degree for this one looks like 3. And the number of turning points would be 3 minus 1, which is 2. And all that looks pretty good as far as what we can see on this graph. Okay, so the graph shows a polynomial. The real zeros are blank. Least degree is this. Okay, so least degree looks like 3. And the zeros, from what we can tell, looks like negative 1. 1, 2, 3, 4, 5. So negative 1, 3, and 5. So the zeros are negative 1, comma 3, comma 5. That is if we are not including the y-intercept. But when it says zeros, they normally mean the x-intercepts, zeros, solutions, or roots. If they had said intercepts, I might want to include this one, but they just said zeros. All right, number 13. Construct a polynomial function that might have the given graph. All right, so it looks like 3 zeros, so we need at least a third degree. The zeros are x, 3, and 5. X, 3, and 5. Or 0, 3, and 5. So for number 13, my zeros, x equals 0, x equals 3, and x equals 5. All right, so if we were to write this as a polynomial, we would say just x, and then this one would be x minus 3, and this one will be x minus 5. So we get something like that just to start us off for the zeros. We don't know if there's a constant out front being multiplied, but that will at least give us a starting point. And so looking at these x that has plus 3 and 5, so A looks like it matches. We don't know that that's a double root because it doesn't touch. So if you notice a graph comes down and touches, it will look something like this when it says touches. Maybe the graph comes down, and then it might come up, and then touch, and then go back down. So that would be like a double root. This is what we call a touch, not an actual cross, since we hadn't seen one in these examples.